Now Theorem 5. Theorem 5 is all about cyclic quadrilateral. Cyclic quadrilateral. If you have, this is a circle, cyclic quadrilateral. We can have cyclic quadrilateral in this shape. The four angles must be touching the circumference. So this is first angle, second, third, and fourth. And if you are labeling cyclic quadrilateral, it has to be labeled maybe anti-clockwise or clockwise. We can also have cyclic quadrilateral in this form. We can have this, we can have it this way. This is also a cyclic quadrilateral. So you can have P, Q, R, S. You can label it clockwise, you can label it anti-clockwise. Now, if you want to prove that the sum of the opposite angle of a cyclic quadrilateral are supplementary, because that is what the law 5 is saying. That the theorem says that the sum of the opposite angles of a cyclic quadrilateral are supplementary. The supplementary angle is 180. The summary of the theorem is just you sum the two opposite angles together in a cyclic quadrilateral, you equate it to 180 degrees. That is what the law is saying. How can we prove that? It will be given, we have a circle. Let's have our cyclic quadrilateral in this shape. This is cyclic quadrilateral. I label A, B, C, and D. We want to prove that angle DAB plus angle DCB is equal to 180 degrees, or angle CAD plus angle ABC is equal to 180 degrees. Whatever we do for these two angles, the same with this. And don't forget, the sum of all the four angles is going to give us 360 for cyclic quadrilateral. So we want to prove that the sum of these two angles, this angle and this angle, we can call it DAB plus angle DCB is equal to 180 degrees. That is opposite angle cyclic quadrilateral, or which is the sum of the two opposite angles of a cyclic quadrilateral is equal to 180 degrees. So we want to go and do little construction here. Let's say this is the center of this circle. Center of the circle, we call it center O. Now let's join OB. Let's join OD. We have it this way. Then this angle, let's label it M. And this one, let's label it N. Which means that from here, DAB, which is angle M plus angle N, is equal to 180 degrees. It can also be implied this way. Now, if you now look at this, this is angle at the center. This is another angle at the center. If you put X here, then we put Y here, you will see that from the theorem 2, which says that angle at the center twice angle at the circumference, you see that S is going to give us 2N. Angle S is equal to 2N. Also, angle Y is going to give us 2M. That is angles at the center twice angles at the circumference. Angle at the center twice angle at the circumference. But if we now look at X and Y, the relationship between X and Y is X plus angle S plus angle Y is equal to 360 degrees. S plus Y is equal to 360 degrees, which is sum of angles at a point. Sum of angles at a point. Sum of angles at a point. Then if we now look at it, our S is 2 multiplied by angle N plus our Y is 2 multiplied by angle M, which is equal to 360 degrees. this is what we can be written as 2 angle M plus 2 angle N is equal to 360 degrees. Since it is addition, we can change it. They can be written like this since it is addition. So 2 is common. We have 2 plus M angle N is equal to 360 degrees. So if we divide both sides by 2, these 2 will remove these 2. Angle M plus angle N is equal to 180 degrees. Now let's go back to our diagram. DAB is N. DCB is N. We can now say that therefore angle DAB plus angle DCB is equal to 180 degrees. This law has been proved. So this is how we can prove that angle at the center, the sum of the opposite angle of a cyclic quadrilateral is equal to 180 degrees. Or we say the sum is equal to 2 right angles. This is how we can prove it.